In this unit, we're talking about limits. So let's talk about what a limit is. The limit of a function represents the y value the function approaches as x approaches some number. So the way we read this is the limit of f of x as x approaches a. We're looking for what y value x is approaching as we get closer. Y value f of x is approaching as the x values get closer to whatever that value is. Now, we don't really care what the value is. So, on this one, we're trying to find the limit of x minus 1 as x approaches 4. I don't really care what the y value is at 4, but what are we approaching? So, we want to get really, really, really close. So, if I go to the left of 4, just a little bit, that'd be like 3.999. 3.99. 3.9. On the other side, 4.001. 4.01. 4.1. Let's see if we can figure out what we're approaching. So in this one's kind of easy to do without even a calculator. It's x minus 1. So x minus 1, that would give me 2.9. 2.99. 2.999. 3.001. 3.01. 3.1. What is the function approaching? So what y value are we approaching? Well, we're approaching 3. Now, yeah, I know that is actually where we get if we plugged in 4 for x. But what about this one? If I plug in 2 for x, I get 2 squared minus 4 over 2 minus 2. I would get 0 over 0. I would get bad, bad, bad. So on this one, I really do have to do some work. So to the left of 2, let's put 1.999, 1.99, 1.9, 2.001, 2.01, and 2.1. I want to find out where we're approaching because I cannot just plug in 2. Let me make sure. Okay. So what I'm going to do is I'm going to go to the grapher and I'm going to put this function in as, if I do a fraction, x squared minus 4 over x minus 2. All right, so now I want to make a table. So I'm going to go to the table feature. And the nice thing about this calculator is I can type in whatever x values I want. So 1.9, 1.99, 1.999, 2. Now, look, when I plug in 2, it says that's undefined, so that doesn't exist. 2.001, 2.01, 2.1. And I'm going to copy this table onto my page. So if I plug in 1.9, I get 3.9. 1.99 gives me 3.99, and this is 3.999. On the other side, I get 4.001, 4.01, 4.1. So what y value are we approaching? Well, it looks like we're getting closer and closer to 4. Let's try the next one. The limit of x plus 3 over x squared minus 9 as x approaches negative 3. If I try to plug negative 3 in, I would get 0 over 0. That's bad. So I want to make a table. I need to think what is just to the left of -3. Now remember, when we're on the negative side, this would be -3.001, -3.01, -3.1. This would be -2.999, -2.99, -2.9, because remember, when we're on the negative side, it's reversed. So I'm going to go in and change my expression. You could actually go in and just edit what it has if you want, or retype it. Squared minus 9. And I'm going to go look at the table again. Now I'm going to have to fill in the values I want. -3.1, -3.01, -3.001, -3. Now at -3, it's undefined. That doesn't exist. Okay, so then -2.999, -2.99, -2.9. And I'm looking at this, and it looks like, so let me copy them into here, because that'll make it a little bit easier. This one has a lot of decimals in it. It says -0.164, -0.166, -0.167. On the other side, -0.167, -0.167, -0.169. So where do you think we're approaching? Well, it looks like it's approaching approximately, and I'm going to put an approximately symbol because it's not exact, -0.167. If we come in from the left side and come in from the right side, we're approaching about the same thing. Let's continue with a few more. All right, so this one, the limit as x approaches 3. So I know we're trying to find 3. To the left of that, since it's positive, okay, so we're trying to find what's happening at 3. So I'm going to go in and edit this one. Actually, this one is the same function, x plus 3 over x squared minus 9. What has changed are the x values, because we're approaching positive 3 this time. So I just need to change these x values to match what I have here. 2.99, 2.999, 3. Ooh, it still says it's undefined, because if I plug in 3, I get 0 in the denominator. That's bad. I'm going to go ahead and copy what I have here. -10, -100, -1000. Okay, on the other side, 3.001, 3.01, 3.1. Now this one's interesting. As I'm coming this way, it's getting more and more and more negative. As I'm going this way, it's getting more and more positive. They're not approaching the same thing. So this gets into a little bit of an interesting topic. If I'm trying to figure out where that reaches, I really can't. And we would say that the limit does not exist. And if you want to have a nice little Mean Girls flashback, this limit does not exist. Okay, but could I figure out where I'm approaching as I come in from the left? From the left, it's getting more and more negative. The way we talk about a limit from a direction is we would say the limit as x approaches 3 from the left. And I'm putting a little dash from the negative side, from the smaller side. What is it approaching? It's getting more and more negative. So if I put in, I'm just going to go up here and change this, 2.99999. Wow, it's negative 100,000. It's getting more and more and more negative. So it's actually approaching negative infinity. Ooh. Okay, this side, if we come in from the right, so we're looking here, we go 10, 100, 1,000. We keep getting bigger and bigger and bigger. So the limit as x approaches 3 from the right, so I'm going to say from the plus side, is approaching positive infinity. So we can actually approach negative infinity or positive infinity. And if we looked at the graph, let's see what's happening at 3. So I'm going to zoom out a little bit. And I'm pressing the minus sign to zoom out. Look what's happening at 3. We have a vertical asymptote. The graph is going to negative infinity on the left side and to positive infinity on the right side. All right. Our next one, the limit as x approaches 0 of x over absolute value of x. So I'm going to put 0 here, because if I plug in 0, I've got 0 over 0, which is bad. Something to the left of 0. Well, actually, let's do the right side first. 0.001, 0.01, 0.1. The negative side would just be negative. 0.1, 0.01, and so forth. So I'm going to go in. I'm going to, and yeah, I can just delete it if I wanted to. Fraction x over. Now, absolute value, you can press your toolbox and choose absolute value here. Absolute value of x. And I'm doing a table. So I'm going to plug in my values for the table. Negative 0.1. Whoops. Negative 0.1. is negative 1. Negative 0.01 is negative 1. Negative 0.001 is negative 1. 0 is undefined. Let's go on the right side. 0.001. 0.01. 0.1. So from the left side, everything is negative 1s. From the right side, everything is positive 1s. So I can't figure out what's happening at 0 because they're not approaching the same spot. So it does not exist. But the limit as x approaches 0 from the left is negative 1. And the limit as x approaches 0 from the right is positive 1. Let's look at this graph because that sounds kind of interesting. Ooh, look at that. So let me put it auto. The left side is a straight line at y equals negative 1. The right side is a horizontal line at y equals positive 1. But at 0, I can't be in two places at once. So the limit at 0 does not exist. All right, let's look at this last one here that we're filling in the table ourselves. And we're approaching 0 again, so all right, so let's change our function. So I'm doing the back arrow, expressions, and you can just delete it and then type in cosine of 1 over x. And notice I didn't put the y equals, but it'll do it for me. So that's nice to know. I'm going to go to display values, and we already had it set. So this is negative 0.839, 0.862, 0.562, whoops, 0.562, 0.862, negative 0.839. This one's interesting. I can't really tell what's happening on either side. So I'm going to look at the graph. Whoa. If I zoom in, it's just going to get worse. This graph is going, like if I back out, it's going up and down and 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 up and down over and over and over and over. And look at how tight it is. I can't tell what's going on. So this one is oscillating. I can't tell what's happening. It's going negative, positive, negative, positive, negative, positive. This one does not exist as well. So if we can't decide where it's reaching, we would say the limit does not exist. Okay. Now, what if we're given a table of values? Can we figure out what the limit is? So the limit as x approaches negative infinity. Well, negative infinity would be going this way on my number line. So -3, -5, -9. What do you think's happening? Well, these numbers are getting bigger and bigger and bigger, right? So it would approach positive infinity. What about the limit as x approaches -3? Well, it is 9. Okay, cool. X approaches 1. Well, that is in the table, 1.5. As x approaches infinity. Okay, so we're going this way, 1, 3, 9, blah, 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 blah. Look at the numbers, 1.5, 1.125, 1.002. What do you think it's approaching? It's approaching 1. All right, the next one is a rational function. So I'm picturing a rational function with vertical asymptotes and horizontal asymptotes. As I'm going to negative infinity for the x's, that would be going this way, -1, -1,000. Look what I'm really, really close to when x is -1,000. I'm really, really close to 1. The limit as x approaches -1 from the left. -1 from the left is going this way. Okay, so 1, and then all of a sudden it's down at 2,000. That's getting really, really big positive, so that's reaching positive infinity. But if I come in from the right, I'm at -1,999. That would be going to negative infinity. So I know I've got a vertical asymptote right here. Let's see what happens at 2. Okay, well, at 2, I don't know what it is, but the left side's at 0.33. The right side is 0.334. I'm going to guess it's probably like 0.33333. I'm going to guess it's like 1/3. And I put approximate. What's happening as x approaches infinity? So if we kept going down this table, we got 1,000. Let's see, 0.334, 0.998. I bet it's approaching 1. Now, what about the limit as x approaches -1 if I don't give a direction? If I don't give a direction, I'm having to look from the left and the right, and the left side's approaching big, big, big positives. The right side is approaching big, big, big negatives. They're approaching two different extremes, so this limit does not exist. So this will be your mission on the homework. You are doing a practice sheet and not a mastery check. So I'm changing it up in this unit. I want you to complete the practice instead of a mastery check.